Welcome to Next Gen Manufacturing. Today, we're going to talk about an industry you probably don't associate with cutting-edge production, construction. And we're going to start by looking at two worlds that have evolved in completely, and I mean completely, different ways. Just look at the phone in your pocket or the car you drive. Manufacturing has become a masterclass in efficiency and integration. But what about the buildings we live and work in? Well, as they've gotten more complex, the process of actually building them has somehow gotten more tangled, more fragmented, and that's the paradox we're diving into. So here's the plan. We're going to break this whole thing down. First, we'll diagnose the industry's massive billion-dollar problem, then uncover the hidden costs, and finally, explore a game-changing solution that's borrowed straight from the factory floor. Let's get into it. Okay, so what exactly went wrong? You'd think that as buildings got more advanced, with all the smart tech and complex systems, the process for building them would get smarter too. But that's not what happened. The industry's response was just to add more and more specialists. This idea actually has a name. It's called Tailorization. You break a big job into tiny specialized tasks. And on paper, that sounds super efficient. But in construction, it's created these walls between professions. The architect, the engineer, the contractor, they're all experts at their one little piece of the puzzle. The problem? They're not always speaking the same language, and no one's really optimizing the whole thing for the person who actually has to use the building. And this isn't just a minor annoyance, a few frustrating meetings. These disconnects add up to a mountain of tangible, measurable waste. Waste that has a very specific and very expensive name. The experts call it the costs of non-quality, or CNQ for short. And this isn't just about a crooked wall or a leaky pipe. It's everything, all the costs that come from mistakes in the process itself. We're talking redoing plans, fixing things on site, endless delays. It's this massive hidden cost that's just baked into the industry's inefficiency. So how big of a problem are we talking about? Well, get ready for this number. Some estimates put the industry's productivity gap due to these costs at 30%. 30. Let that sink in. Nearly a third of all the effort and money poured into construction could just be waste. Now, compare that to the razor-thin single-digit profit margins that companies fight for. It's a huge opportunity. Now, here's where it gets really interesting. When you think of construction mistakes, you probably picture something happening on the actual job site, right? A misplaced beam, a bad installation. But look at this. The data shows that only about a quarter of these costs happen on site. A whopping 75% of them, they start way before anyone even breaks ground. They happen during the design and planning phase. And this chart just nails the problem perfectly. See that first big bar? The vast majority of a project's costs are locked in by decisions made right at the very beginning. But all the arguments about money, all the financial stress, that happens way later, during construction. By then, it's way too late. The expensive mistakes have already been baked into the blueprints. So, how do we fix this mess? Well, to find the answer, we need to look back to the world of manufacturing. Because guess what? They faced this exact same problem decades ago, and they came up with a pretty brilliant solution. The solution is called concurrent engineering. The old way of building is like a relay race. The architect does their part, hands the baton to the engineer, who hands it to the contractor. Information only flows one way. Concurrent engineering says forget that. It turns it into a team sport, where all the key players are on the field together from day one, working together to optimize the entire project. Proust said the real voyage is not in seeking new landscapes, but in having new eyes. And that is exactly what this is about. This isn't about some fancy new software or a miracle material. It's about a fundamental shift in how you see the entire process of building. So what does this new approach actually look like when the rubber meets the road? Well, it's built on a few key ideas that basically flip the old way of thinking completely on its head. The first one, and this is the big one, is called functional analysis. Instead of starting with how you're going to build something, we need a 6-inch concrete wall here, you start with why. What does this thing actually need to do for the end user? Defining the why before the how is a simple switch, but it opens the door for so much innovation. And what that does is create a genuine value chain. Every expert is suddenly both a client to the person before them and a supplier to the person after. They have to actually communicate and explain things, not just throw decisions over the wall. It forces a conversation where the goal isn't just to protect your little silo, but to make the final product better for the only person who really matters, the user. The whole process gets organized into 3 clear stages. First is programming, and that's all about defining the why from the user's point of view. Second is something called projectation. That's designing the what, the spaces and systems that will deliver on that why. And only then, at the very end, do you get to realization, which is figuring out how to build it. This way, the user's needs are the guiding star for the entire project, from start to finish. I know, this can all sound a bit abstract. So let's look at a super simple but really brilliant example of what this shift from how to why actually means in the real world. It all boils down to a fundamental question this new approach forces you to ask. Who's really in charge here? Is the design supposed to serve the construction technology, or should the technology be serving the person who's actually going to use the space? All right, check this out. It's a tale of 2 bathrooms. On the left, you've got the standard tech-driven design. The layout is based on the most efficient size for piece of concrete equipment. And because of that constraint, the bathroom gets shoved into the middle of the apartment. No natural light. Sad. Now look at the right. This is the user-driven design. It starts with a simple need. The user wants a window in their bathroom. That why changes the layout, which then dictates the technology needed. And the amazing part? The source material for this says this much better. User-focused design was done with no increase in cost. That one simple bathroom example shows you the incredible power of just shifting your thinking. When you zoom out, the implications for the future of building are absolutely profound. When the construction industry adopts a core principle from next-gen manufacturing like concurrent engineering, it can finally move from constantly managing conflict to fostering real cooperation. It creates a shared language, it links design to the entire life of the building, and it creates a system that can actually learn from past projects and continuously improve. It's a win-win-win. So when you boil it all down, it comes to this fundamental choice. And it's not just for construction, it's for any modern industry. Are you going to spend all your energy managing conflict between your teams, or are you going to foster true cooperation from the ground up? And that leaves us with one last thought. If an industry as old, as complex, as traditional as construction can be revolutionized by these principles, what other big systems in our world are just waiting for their own next-gen moment? What else is waiting for us to see it with new eyes?